looking into our next laboratory program, which is create and rotate a triangle about the origin and a fixed point. So this is one program which comes in the part of rotation. So the concept which we put on here is two-dimension transformation. Of course, you can also apply it for the three-dimension, which we actually looked in spinning color cube or rotation of a color cube. Those are the topics which we can actually look into. Anyhow, this is one of a lab program, and you can also consider it for your development of projects. So yeah, let's start then. So yeah, basically what is that we look here? What does the program specify? Program specification is very simple. I should have a I should have one particular triangle. I should create the triangle, and I have to move it. Basically, I have to move the triangle, and you can prepare any triangle, but they have specified triangle only. So you have to take care of preparing a triangle and rotation of a triangle in origin, as well as rotation of a triangle in a given coordinates, right? So question says very straightforward. Create and rotate a triangle about the origin and a fixed point. So origin is, without giving any values, you can easily add it up without any change. That is, you consider the default point as 0, 0. So 0 will be the x and 0 with respect to the y. The other case is you also need to get it from a fixed point. That means a user has to specify those points which he wants to print. So yeah, looking into where does our execution of a program starts from. Execution of a program starts from our main. Before going there, I'll just give out what exactly we mean by rotation in a given origin and rotation with respect to a fixed point. So whenever we're speaking about the origin at rotation of a triangle at origin, so we need a reference point. For my case, this is what I call it as an x. So this is my negative x, and I also have a y axis, which is my negative y, and the other one is positive y. So this is my what we call as the origin point, and the origin, as we all know, it will be 0, 0. So considering this as an example, you have to create a triangle, right? So it depends on you whether you want to put this origin as one particular vertex for a triangle, or you can also make use of the other way, where you can also create the triangle where this origin will be at the center of a triangle. You can also do in that, or any of these edges. If in case this is my triangle, you can also make the triangle as the center part itself. It's your wish, right? Or it can also be in this way, where you have a triangle which is actually making sense of this way also, or you can also create in this way. It's your wish, right? So nobody is putting any question over there, because the question is straightforward. The question is specifying that kindly create a triangle and you just run it. So looking into that part, so we'll consider a triangle, and the program goes in this way. Okay, the other thing is, if I want to rotate a triangle at a given origin, right? For my program here, I am considering this as an origin, and for the next case, it depends on how much time you want, or how much rotation axis or rotation angle you want. It all depends on how much you actually specify. So usually I take it with 1 degree each and running at the speed of the how much I can render. So 1 degree will be very small. Let me take it for 30 degrees at least. So 30 degrees, my triangle will be over here, let's assume, and I have my triangle rotated over here, right? So assuming that the degree is 5 degrees, so for the next particular 30 degrees, my triangle will be somewhere uh, over here. Okay, so main intention is I have to rotate the triangle based on the values given at the fixed point, or it can also be with respect to the origin. So do we have any people waiting? No. All right. So looking into the code here, so there are some basic rotation angles where you are initially rotating with. You can also specify from where to start. That's also possible. What is the rotation angle initial value? What you are giving, that can also be specified. For now, I'm taking it as 0 and 0 for my easy consideration. If you want to be starting with any of the values, you can always initialize. So coming back to the program, it's a very simple, easy program, provided you have to understand how to draw a triangle and how to rotate it, or how to translate, right? So rotate, translate, rotate, translate, rotate, translate. Basically, that's how it works. And here we also look into the simulation of the other important part. I have used mouse event here, so we also need to provide what these mouse event actually specify on. So yeah, execution of a program starts from our main, and yeah, we have a main method here, and okay, before starting itself, before the execution starts, I am actually getting few values from the user here, the x and y. Why? Because the question states it can either be in origin or at the fixed point. If the examiner asks for, okay, I need to start not with the origin of 0, 0, I want it from with x, y, right? Say 30, 30 or 40, 40 or 50, 50, whichever you actually specify. All right. So first thing is enter the fixed point for the rotation. So we have a fixed point here. What is our fixed point? We get it and save it in the values of x and y. So as the comment says here, getting the user's coordinates to rotate, right? From where we have to start. And the next thing is initialize the graphic system with the argument count and the vector value. Next is, okay, is this program 3D? No, it is not 3D, so not needed with the using of glut depth. So it's a two-dimensional rotation. If it is just a image of translation from here to here, a single buffer would have been perfectly fine, but it is a rotation, so we need two buffering. So we initialize, or we specify display mode to be stating as a glut double. Followed by the next thing is you have to create a given window, or before that, for that window size is 800 by 800 with whatever the clipping plane or your window where the output will be seen. So that will be the window size 800 by 800. And we also have, where are we starting from? We are starting from 0, 0 location. I'm not speaking about the image here. Anyhow, the glut window position should be starting from 0, 0, and the name for that particular window will be given as create and rotate triangle. This will be the name of that window. So we call the init method. So init method will actually pre-initialize with whatever we are in needed for specifying our output here. So we'll go to the init method. Very simple. Init method usually has a clearing buffer bit. Yeah, clear the color previously, whatever was there. In other words, 0, 0, 0 refers to what? Which color? 0, 0, 0 specifies to which color, guys? If my red component is 0, green component is 0 and blue component is 0, which color do we have? Obviously we are setting it to a color black, so my background will be a black color. So yeah, I'm drawing something, so I need some projections here dealing with the values of the x, y and z, because you need to translate every time once you rotate. And also the load identity, of course we are not rotating, in other words the image we are making it to rotate, so that calls for the glue ortho 2D, that is xy objects, and we use the matrix view. So we are initializing these are the prerequisites for the initialization. So we'll come back to the display method. So we have a display method. Before the display method here, we will also speak about our event, right? So the mouse event, or not exactly the mouse event, sorry, we are creating a menu event, right? Not the mouse. Menu event, automatically we have some layout which should be what button when I press, I need to get the given menu, and in the menu what all should be there, what should be the first one, what should be the second one, everything you need to specify. So as you need to tell the compiler here that I'm using a event driven application, so you need to specify glut create menu. All right, so menu event will be specified. Next is yeah, once you specify that I'm using a menu here, you need to specify what exactly is the button which you want to invoke the menu event. So here I specify it as a right button, right? If you want to be specifying with the left button also, you can utilize it. You can also actually gain it. You can specify which exact menu button. It can also be a middle button also, right? Glut middle button, glut left button, glut right button will give you attach the menu. That means whenever you press a right button, you have that menu clearly open on the window. So I'll just run that particular application for easy understanding here. I won't be dealing anything with respect to the display. We are just starting. So as I said, whenever I run the program, it asks for two important things. One is with the x value or the x component and the y component. So I just specify it as from the origin, I want it to be 90 pixels from x and 90 pixels from the y. So it gained it. It took the value. It has taken the value, but still here, as you can see, this is my origin 0, 0. All right, so this is my origin 0, 0. And as you can see here, what are my menu entries? Menu entries are three things: rotate around origin, rotate around fixed point, and stop rotation. These are the three major things. So based on these values, you give us what exactly it has to do, what exactly it has to do whenever that event has been pressed, or that menu icon has been pressed. Okay. All right. So yeah, so I'm pressing a right button over here. So if I press the right button, it is giving me three options. So rotate around origin, rotate around fixed point, and stop rotation. These are the menu things which I was actually specifying. So what do we have on the first case? So what do we have on the first case? That is rotate around origin. So if you click on the right, if you click on the right button, you get rotate around origin. That's the first one. Second one is rotate around the fixed point. The third one is stop rotation. I guess this is you got it. So it is starting from the origin point of 0, 0 with the window here. 0, 0 is the window size, and 800 by 800 pixel is actually your, this is x is 800 pixel and the y is 800 pixel. All right, I guess we don't have any doubts over that. Once you actually specify it, then we are looking into the display method. So once we go to the display method, what are the things which we do? Before that, as I said, whenever you press the option 1, what should happen? Whenever you press the option 2, what should happen? Whenever you press the option 3, what will happen? In other words, what are these options 1, 2, and 3? 1 is for rotate around origin, 2 is for the rotate around the fixed point, and the third is with respect to the stop rotation. With the stop rotation. So, all right, we'll come back to the display here. Display method is we are using some colors in the buffer bit, and as dealing with respect to the rotation, we need to load the identity matrix with x, y, and z value, which we actually specify as we discussed in 2-dimension transformation and 3-dimension transformation. So the other thing is I'm actually setting up with the color of 111. So what do you mean by what color do we get if I add one components of red, components of green, and components of blue completely? As we all know that we get the white. White is a color, and what it is doing is it's drawing a pixel of 0, 0. It is plotting it, right? Basically, if you can see over here, there is a pixel of white, right? So this is a white color which actually is printed over using this particular draw pixel method. So the next question is, unless until a user gives 0, 1, or 2, I cannot start with the process. So get to know which exactly the button has been pressed, which exactly the event within a menu, right? So has been pressed. So the first case is rotate with respect to the origin. That means we have taken it as the first one, rotate about the origin. So it starts rotating. We look into the the code here, what exactly is happening. So it is checking if where to rotate is equal to 1. That means it is rotate around the origin. So if you are rotating around the origin, initiate the translate of x as 0, translate of y as 0, and rotate angle. What was the angle which you have given before? Rotation angle was 0. That is why exactly whenever I'll just rerun it before the execution, my rotation will be 0 itself. No, nothing has been started. It is in the 0th 0 angle with respect to the rotation. So gradually it starts with the incrementation of a value, right? So what is the value which I have given here in the display method? My rotation angle I'm incrementing with the value of 0.1 degrees, right? So this is the amount of rotation angle. If you increase this particular rotation angle, automatically it will be running pretty fast, right? I'll also show you that if I'm running it with each increments of 10, right, it will be a very faster one. All right, so create a rotate of the origin of a fixed point. Okay, so running with the origin, can you see it's running like a fan now, right? Why? Because of course the speed defines how far or how many calculations it is doing. This can also be utilized in your program. You can create a windmill out of it, right? So you can just draw a particular pole, and you press some button. So once you press some button, automatically this windmill will increase its speed. Okay, so we can simulate. You can actually take that as one project here, right? The code is already here. You just create a sun over here, and background as a white, and a sun with an yellow color, and you provide some background effects. So if I press on the right button, if you specify wind is normal, wind is moderate, wind is slow, or wind is very high, wind is outstanding, do some of your visual effects which you can give, and destruction of a wind pole can also be done, whatnot, right? A small example here. What is the only thing which I did? I rotated with the value of 10. If I just make it as a with the case of 1 degree, that means I'm actually making more number of computations, more number of angle, more number of rotations. So just specify with the values and create. This is the every incrementation of 1. That means in each and every second, probably it is running it is making a calculations of 360 times nearly. So what I did was, if you want to make it as pretty low, right, very low, you can also do it where you can say that, okay, this fan is pretty slow in working, or this triangle, not a fan, it's a triangle. So fixed point rotation, it's rotating at a very small pace now, right? You can do your own project out of it. Nobody has done till now. If you can give me, anyhow, we'll be looking into the, I'll share you the file, and you can come up or give the particular names of it, right? Don't go for complicated applications. As I said, go for the minimal one. Anyhow, this is the number of degrees. So each computation might incrementation of the angle is 0.01 degrees. All right, so we'll come back here. All right, so what are we doing here? If it is rotation at the origin, increment at these values and come back here, then translate with x and y value with the positiveness of the translation, and what was the rotation angle which we gave? 0.01, right? So 0.01. Here also I'll make it as 0.1. Why? Because this becomes a too much slope. All right. So I'm running it again. So I'll be giving with 19 and 90 values. So rotating with the origin, it is making it. I can also rotate from a fixed point. So we'll come back to the fixed point once we finish with the origin rotation. So I hope, any doubts here with what exactly this statement does here? So I get to know that, okay, a particular user has pressed the first event, and the event which has been taken, I'm pre-initializing few values here. Consider the x as 0, y as 0, and rotation angle as 0.1. All right. So what if 1 has been selected, then I have to translate it. Anyhow, whenever we saw the case, we always need to rotate, translate, and rotate it, right? In other words, if it is at some location 0, I have to bring it to the origin, that is translation, then I have to rotate it, then I have to inverse translate it. That means you take it, you do whatever you want, you have to put it back. Right, that is why you see GL translate with x, y, 0 here, the previous value, get it to the actual value of 0, rotate it with whatever the rotation angle which you have, then you translate it back. That means your negative or inverse translation which we specify. Once you do that, create a triangle. So you know how do I create a triangle now? I know which is my origin now, x and y. Those are my translate with x and y value, because initially my x and y was 0 and 0. So I'll send it for the creating of a triangle. Now search for the triangle method somewhere over here. So triangle will now initially have 0 and what value? 0 and 0 value. Right. So what is the color which you have given? Red. That's why you see the triangle as a red. So once you create a red color, create the polygon. Create the polygon from 0 and 0. Then whatever my value of x is, 400, plus whatever the value of y was, 300. This is my initial vertex, this is my second vertex, and this is my third vertex. All right. So my triangle here, I'll stop it for some time. Let me stop it at the original rotation. Rotate. Okay. Yeah, so assuming that this is my 0th axis and y axis which I have sent, so automatically from taking it as an origin, it is calculating with the value of x. So initially what will be this vertex point? This vertex point will be 0, 0. The second one will be, the second vertex will be x plus 400, y plus 300. What is 400, 300? 400 with x, 300 with y, somewhere over here. Similarly, what about the other one? What about this vertex? This is, as we know that y is 0 here, right, initially. And what about the x value? X is 400. So that's why you see the value of this. If you want a perfectly a triangle here, you can specify it as 300 and 300, 0, 300, 300, 0. I think this will not give you obtuse sort of a triangle here. So if we run it, we'll be getting a equilateral triangle. So not exactly equilateral triangle, but with the value. So if I want the equilateral triangle, then we have to plot it. So yeah, how do we get that particular triangle? Because nobody has specified anything as an equilateral triangle. If in case a user is asking for, I need an equilateral triangle. If you want to plot an equilateral triangle, you always go with this point. So assuming this as 0, 0, then I have taken this as 300, 0. So 300, 0, and what will be the midpoint of this particular case here? So it will be 150 and 300. So 150 and 300 will give you an equilateral triangle. As simple as that, right? Let's change that particular value with what 150 and 200. We'll save it, and we'll look into our case here. Anybody has any doubts here, guys? If not, kindly can mute it from your side. All right, some brilliant is outside. Raghavendra, where exactly are you, buddy? Okay, it's somewhere outside, I guess. So, giving the value of rotation, you can give any value. It's not only the 90. I'll give 60 also. 60 also. So now it's an equilateral triangle. Yes. So rotating it, it is giving me the rotation of an equilateral triangle. So these are the changes which you can actually look into, right? So many cases might be there, many cases can be there, but depends on whatever the questions external can ask you, and he or she can create it, right? So yeah, so I hope we spoke about the first with the origin angle rotation. Yeah, we created the triangle now. We created the triangle. Again, we are coming back. Again, we are coming back to where? Let post redisplay. Come on. Again, go to redisplay. Right? So again, start with the values. So now, what will be my translate X and what will be my translate Y now, guys? It will no more be my value of 0 and Y with respect to 0. Why? Because as we already saw that how exactly it was working, right? Initially, with the incrementation of one value, my X value was also incremented. My Y value was also incremented, right? So now the case has changed. Every time for the every incrementation, I have these values which will be changing. That means my new translate X value and my new translate Y value both will be different. Every time, each and every time it will be different. So what is the case? Why do we need it as a different? What is the use of it? We want to make it as a rotated triangle, right? So every time it rotates, it increments with the value of X. We'll look at one example here. So grid post redisplay will do something. So we know that what is my translate of X, translate of Y. What is my new translate of X and new translate of Y? What was the value which was incremented in our triangle here? This what was my older value of X and Y, right? So every time you increment the value, this will be done, right? For the next iteration, increment the angle, increment the value of X and Y. That means every degrees here, we are adding few pixels values. We are adding the length of X and Y. So it gives us a particular way of this triangle, right? So as I said, it can not only be a triangle. I can also specify some what do you call? I can also specify another angle itself. So you can call this as a rectangle, right, or some other angle. I'm not giving it as 150. Why? Because it gives me the same angle, right? So let me give it with 550, or where was my this thing? So if I want to be in a rectangle way, so this will be what, 0 comma 0, and what will this be? This will be 300 comma 0. The second case will be 300 comma 0. What about the third one? So let me call this as 500 with x-axis. Now 300 with x-axis, and we want a rectangle, right? So 200 with y-axis, and what will this rectangle value be, or the values of it? It is 0 with the x-axis, and y is 200, so it will be 0 comma 200. So let us specify this value 0 300, and we shall look into its questions. May be different, right? They might be differing. So my value will be x plus 0 with 300, and what will be the other one, 300 plus 200. Then what will be the fourth one? Fourth one will be again 0 and 200. So let's run it, and we shall look into it, how my triangle will look like. Of course, everything is all about the trial and error method here. Yeah, we got some other triangle value here, but still specifying. It might be a case that it is undergoing within this. All right. You can specify. Did I save? Yeah, I did save. Running the application 60. All right. So with the first case was with the origin. We saw about the origin. The second case, what if the user presses, or whenever a user presses the second event, what will happen when a second entry has been done? So if my option is 2, where to rotate will become 2, will be equal to 2, right? So where to rotate will be equal to 2. That means I have to consider this. If my way to rotate is equals to 2, you have collected the value of from where I should start. That is my user defined x and y value. My user defined x and y value will be taken into consideration. From there I'll start. So whenever you want to start from there, you assign this. These are the only difference here, guys. Look into it. These are the only difference here. 0 and 0 for origin, and x and y I'm specifying some value because I'm setting the translation to whatever the user says, whatever the customer says, whatever his need is, from where I have to start. Similarly, here what you see, incrementation of 0.1, that means rotation is happening for each and every 0.1 degrees, right? So again, here my simulation will be pretty slow. If you want it to be much more faster, yeah, you know it, what to do. And the other thing is, you're creating your new vertex, right? So previously my vertex was at this origin. So you need to plot it at x and y. So once you do it, you have a blue color which you have here. That means your rotation of a triangle is no more in origin. It is at 60 pixels by 60 pixels, because the last time whatever the value which I have given here is 60 by 60, right? Similarly, if I rerun it with some other value of, let's assume 500 by, not 500, 500 will be pretty far. So we'll take it as 200. So 200 pixel by 300 pixel. From where to where will this change be? From the origin, from the white point which you see. From there, it will be moving on to the other case. So this will be your 200. This will be your 200 by 300 pixel. So what was the question? The question was moving from the origin and the other value which is specified. So yeah, every time again the same thing will happen. The amount of rotation angle will be used and mark the, okay, this we saw, and we started plotting the picture, and we come back to here. And what is that thing which does the same translate? That means you take the value, you construct a triangle, you rotate it, again give it back. That's what the same what do you call the positive translation, rotate, and inverse translation. All right. So you do that. Again, you create a triangle, then you go for glut post redisplay. Means it is running, 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 right? Unless where? Unless you go for stop rotation. So basically I didn't give any of the code here for the stop rotation, because if I don't give anything, then nothing will happen. So basically, if you see here, my rotation with respect to origin is happening and fixed point is happening. All right, done with everything. Stop rotation, the position will stop. That will halt. All right. I guess this is a beautiful program which we have created, and I think any other thing. All right, draw pixel is what we didn't tell. I didn't tell you here. Draw pixel is actually a function. Whatever the value which you are sending here, for my one for initially at origin I'm sending 0, 0, and for the next time in the translated, that means I'm going to some other place and I'm setting up with the value of x and y here. Whatever the customer gives or the user gives, that value I take it and I send to draw pixel. So I'm overriding the draw pixel here with the values. I'm setting up the pixel point as 5. That is why you see this much big particular white dot. All right. So if I take it, if I make it as a 1, it will just be a very small number, a very small number to see. All right. So you can specify whatever the pixel value which one. Can you see here? The white dot is only one pixel will be highlighted. Only one pixel will be highlighted. If I make my pixel size as 5, that means the 5 neighboring pixels will be made as 1. Right. So that's the beauty of this particular application. Uh, I think that's it for this particular example. Thank you.